Hello students, welcome back to the third video of this playlist. So in this video we will be solving question number 3 from S1 May 2024 paper. So let's see what's the question number 10 is about. So basically the concepts behind question number 3, it's from chapter number 2 of your statistics 1 textbook, which is named as uh, measures of spread and location. Location and spread, yeah, measures of location and spread. So in order to be able to solve this question, that is question number 3, definitely you should have practiced questions and you should have gone through the concepts of chapter number 2 of your statistics 1 textbook. So let's get started with question number 3. Let's see what the question is about. What the question says: the length x millimeter of 50 pebbles are summarized in the table below. Okay, the length of 50 pebbles is given in this table. Okay, so length frequency, you can see there's one column for length and the next column for frequency. So a histogram is drawn to represent these data. uh, a histogram is drawn to represent these data. Okay, so the bar representing the class x greater than or equal 32 less than 36 is 25 centimeter wide. Its width is 25 centimeter and it's 7.5 centimeter tall. So the bar in the histogram of this data, the bar that is representing x greater than or equal 32 less than 36, it's what, how much width? 25 centimeter wide and 7.5 centimeter tall. Now the question asks in part A to calculate the width and the height of the bar representing the class x greater than or equal 30 less than 32. Okay, fine. So we need to find out the height and the width of this class x greater than or equal 30 less than or less than 32. Okay, so at first consider, like, we can do this using the unitary method, like 2.5 centimeter, it's for how many units? Like from 32 to 36, how many units are there? 4 units, right? 33, 4, 5, 6, yeah, 4 units. So for 4 units the width is how much? 2.5 centimeter, right? So 4 units width is how much? Width is 2.5 centimeter, right? So for 1 unit width would be what? 2.5 over 4, right? So what we need for how much centimeter? So for how many units? This is 30 to 32, that means 2 units. Okay, for 2 units width is how much? 2.5, that is 5 over 2 times 2 over what? Over 4. Let me write it separately since small place. Okay, so 5 over 2, that is 5 over 4, that means 1 point, how much? 1.25 centimeter. Okay, so width is how much? 1.25 centimeter. Done, we got the width. Next is what we need to figure out. We need to find out the height of the what? Bar. Okay, so how can you find out the height of the bar? Okay, look, the height of the bar is basically dependent on the frequency density, right? We know that on a histogram along the y-axis we consider the what? We consider the frequency density. Okay, so they have said it is what, 7.5 centimeter tall. Which one? This class. This class is, this bar is 7.5 centimeter tall. Okay, for this class let's find out the frequency density. How much is this? 20 over what, 4. So 20 over 4 is what, 5. That means for 5 frequency density, now for 5 frequency density, height is how much? Height is 7.5 centimeter. Okay, so for 1 FD, what would be the height? Height is how much? 7.5 over 5 centimeter. Fine. So for how much? Let's see the class for which the question asked for. Let's find out the frequency density of that class. Okay, for that class, what's that class? 30-32. Okay, 30-32. This is 16. Frequency is 16 over 2. That is what, 8. So for 8 frequency density, what, height is how much? Height is what, 7.5 over 5 times what, 8 centimeter. So what would be the value? 7.5 is basically 15 over 2. So 15 over 2 times 8, there is 4. So 60 over 5. So 60 over 5 is basically 12 centimeter. Okay, so 12 centimeter. Done. We got the height. Okay, so we got the width. How much? Width was 1.25 centimeter, and we got the height as how much? 12 centimeter. That's it. Done. Next, for part B, the question asked that using linear interpolation, we need to use linear interpolation to estimate the median of x. Okay, linear interpolation. This is an important part of this question. Linear interpolation, most of the student like feels very difficult to consider the formula for linear interpolation, right? So let me show you a very easier way to consider that process, linear interpolation. So we need to find out the median. So right at first, for the median, let me show let me write you a very simple formula. Using that formula you can easily find out the median. That is, we need the Q2, right? Q2 equals to, use this formula, L plus N over 2. Since it is Q2 the median, that's why it would be what, N over 2 minus FC times H over FM. You don't need to write this formula in the exam, just use this sequence, this pattern. Okay, so L is basically the lower limit of the what, of the median class. Okay, so this is L. N over 2 you can understand. FC is basically the cumulative, okay, cumulative frequency to the what, to the median class, to the previous class of the previous class. Okay, of the previous class, to the median class. Okay, this is the cumulative frequency of the previous class of the what, median class, and H is the class width, and FM is basically the frequency of the median class. Okay, frequency of what, median class. This is the FM. So let's find it out easily, you can get it directly. Look, Q2, at first consider N over 2. Where does this N over 2 lies? Let's see. n over 2 total number of data is 50, so 50 over 2 is what? 25. So where is 25? 2 plus 16, that is 18. 18 plus 20, that is what? 38. So that means the Q2, this is the median class. Okay, it lies, the Q2 lies here. So the lower limit of the median class is what? 32. The lower limit of the median class is 32. So 32 plus n over 2 is what? 25 minus cumulative frequency of the previous class to the median class. This is what? 20. 2 plus 16, that is 18, right? This is what? 18. So n over 2 minus 18 times h. H is what? The class width of the median class, that is 2, over frequency of the median class, that is 20. Am I right? Yeah, class width is 2, and class width is not 2, it's 4. Okay, class width is 4, and frequency of the median class, this is 20. Fine. So 4 over 20. So that would be what? 4 over 20. So what would be the value for Q2? So 25 minus 18 times 4 over 20 plus 32. So the value for the median, it's basically 33 point what? 4. 33.4. This is the what? Median. Done. Okay, so what's next? Next is part C. Okay, next is what? Part C. For part C, they are asking, okay, they said the weight W grams of each of the 50 pebbles is coded. It has been coded using 10 y equals to what? W minus 20. These coded data are summarized by summation of y is given, summation of y squared is given. Okay, fine. So part C asks to show that the mean of W is 40.8. Mean of W is how much? 40.8. This is the concept from coding, that is from chapter 2, right? So for part C, at first let's find out what? Let's find out the mean for y. Okay, that is y bar. Y bar equals to what? Summation of y. Summation of y is how much? 104. Yeah, 104 over 50. That is 104 over what? 50. 104 over what? 50. So that is how much? This is basically 2.08. 2.08. Now we need the value for x bar. So just put this value into the coding formula. Okay, so the coding formula is 10y equals to 12 w minus 20. So 10 times y bar, so that would be what? 10 times, so 10 times y bar equals to what? W bar minus 20. So we need w bar. So w bar would be what? W bar equals to 10 times 2.08 plus what? Plus 20. So what would be the value for w bar? That would be 20.8 plus 20, that is 40.8. The w bar is what? W bar is 40.8. Okay, next they asked for what? The variance, right? No, this is in part D. So part C is what? 40.8. It has been showed. Okay, part D, calculate the standard deviation of W. We need to calculate the standard deviation of W. Okay, so the coding formula is 10y equals to W minus 20. So from there we can make the, if you make W the subject, what you will get? 10y plus 20. Okay, okay, so at first let's find out the variance. We can let's find out the variance of y. What would be the variance of y? The formula for variance is what? The formula for variance is sum of x squared over n minus the mean squared, isn't it? Okay, so this is the formula for what? Variance. And square root of variance is the standard what? Deviation, right? So let's find out the variance of y in part C. Let's find out the variance of y. So what would be the variance of y? This will be sum of x squared over n minus the mean squared, right? So sum of x squared, sum of y squared, sorry, it's y variable, so it should be y squared. So y squared is how much? 233.54. So 233.54. This is sum of y squared over n is what? 50, right? Minus the mean squared. What was the mean we got? This is 104 over 5. That's what? 2.08. Yeah. Minus the mean squared. This is 2.08 squared. This is the variance of y. Okay. So let's find it out. So 23.54 over 50. This is basically 4.6708 minus 2.08 squared. It will give you 0.3444. This is the variance of y. Okay, so y can be written as what? Y can be written as we got the equation for y is given as w over 10 minus 2, right? Okay, we should have made y the subject. Okay, if you have made y the subject, then you will get what? Y equals to 1 over 10 w minus 2. Fine. So y can be written as 1 over 10 w minus 2. So let's put it there. So variance of y is basically variance of 1 over 10 w minus 2. This equals to how much? 0.3444. Okay, now variance of 1 over 10 w minus 2 can be written as what? 1 over 100 times the variance of w. This is equals to 0.3444. How? This is basically, coded formula, like the coding formula. So for coding formula, only for multiplication the variance gets changed. Okay, how it changes? It changes by the square of the multiple, right? So variance of w is what? 100 times 0.344, that is 344.4, isn't it? It's 34, no, it's 34.44. Yeah, 34.44. So this is the variance of w. So we need the standard deviation of w, right? So standard deviation is what? Square root of what? 34.44. So what you will get? This is basically 5.87. Yeah, variance is 5.868 something. So we can round it up to 3 significant figures. 5.868. It keeps going. So we can round it to what? 3 significant figures, that is 5.87. 3 SF. Okay, before rounding, how many decimal places they consider? 40.8. Yeah, 2233.54. Okay, 1 decimal place or 2 decimal place will do, no problem. Okay, so done. We are done with part D. We got the standard deviation, that is 5.87. That's it. Okay, next, the weight of a pebble recorded as 40.8 grams is added to the sample. Without carrying out any further calculations, state giving a reason what effect this would have on the value of in part 1 the mean. Okay, the mean, what effect it will have on the mean. So the weight of the table of the new added table is 40.8, and we know that the mean, what was the mean weight? Yeah, mean weight was also the mean weight was, yeah, the grams, right? Okay, y grams, w grams, yeah. The mean weight was also how much? 40.8. So that means the new added table has the same weight as the mean of the whole data. That means adding this value into the data will not change the what? Mean. The mean will remain unaffected. Okay, so part 1 is that the mean will remain unaffected since the new data is equal to the mean of the whole data. Okay, so this is part D. This is part E1. Okay, mean will remain the same. Okay, since 40.8 is the mean of the what? Data. That's why. Okay, so part 2. Now for part 2 they asked like what it will impact, how it will impact the what? The standard deviation of W. Okay, let's consider one thing. Let's consider a concept here. This is a conceptual question. For standard deviation, what does standard deviation mean? Standard deviation is basically a measure of what? Measure of spread, right? So it represents the it represents like how the data values are spreading out, or how the data values are varying with respect to the mean of the data. Okay, so 40.8 is how much? The mean of the data was 40.8. so the new data that has been added, this is also what? 40.8, which is equal to the mean of the data, right? So since 40.8 is the same as that of the mean of the data, and standard deviation represents what? Considers the measure, the spread of the data with respect to the mean. So that means 40.8 is a value that lies within what? Within the standard deviation of the data, right? So the difference is what? The difference from the mean is 0. That means due to the addition of this data, the spread will increase. No, never. It will decrease, because 40.8 it is equal to the mean of the data, right? So that means there is no difference between the new added value and the mean. Therefore the measure of spread, that is the standard deviation, will decrease. Okay, because the data values are getting closer to the what? Mean of the data. Fine. So that's why the standard deviation of W will what? Decrease. Okay, because the value 40.8 it is equal to the mean, that is it lies within one standard deviation about the mean. Okay, standard deviation will what? Decrease since 40.8 is equal to the mean of the data. Okay, if it is equal to the mean of the data, then what will happen? Data, so it lies closer, not, you can say closer to the middle of the data, that is closer to the mean, or you can say so it lies within one standard deviation, one sigma about the mean. Hence data values gets closer. Hence data values gets closer to the mean. That's it. closer to the mean, and that's why the standard deviation of the data will what decrease. And that's all about question number 3 from May 2024 S1 paper. That's it.